All right, so we talked a little bit about the domain and range of a function, but and how that looked on a graph. So now we're going to do some problems where we're asked to find just the domain of a function, and we'll go into some of the restrictions and how we find what that is without having to do the whole graph or anything else like that. So the first problem we're given here is g of x equals square root 3x plus 12. And what we're asked is, what's the domain? Well, if you remember, the domain is the possible values of x. So what we're asked here is, are there any restrictions on what x can be? Well, since g of x is a square root, and the square root can't be negative when we're talking in this case. I mean, for our purposes, the square root can't be a negative number. So the restriction is 3x plus 12 must be greater than or equal to 0. So, and if we were to evaluate this inequality, we would say 3x has to be greater than or equal to a negative 12. We subtract 12 from both sides. And divide both sides by 3, then we get x has to be greater than or equal to a negative 4. Right? Then negative 3 times a negative 4 is negative 12. Negative 12 plus 12 is 0. If it's less than negative 4, then you'll have a negative number here, and you won't be able to evaluate that function. So our domain is x is greater than or equal to negative 4. There's no restrictions above that, so we would write that as, in interval notation, we'd say it can be equal to negative 4, so we'd use a bracket, negative 4 to infinity. All right, so the next problem, scroll down here, is we're being asked to find the domain of f of x equals the square root of 42 minus 3x. And we're going to have the same restriction here on what our function can end up being. It's got to be greater than 0. So this 42 minus 3x has to be greater than or equal to 0, or else our square root would be negative, and then we'd get an imaginary number. So if we add 3x to both sides of this equation, we get 42 is greater than or equal to 3x. Divide divide both sides by 3, and then we get 14 is greater than or equal to x. So that means that x can be equal to 14, but it can't be greater than 14. So that's going to be, otherwise we would have a negative number here. So if we write that in interval notation, because we're going to do that because we're going to start from negative infinity, right? Because if it's a negative number, then a negative 3 times a negative number would give us a positive, and we're fine with that. So it would be negative infinity up to and including 14. So that's what the domain would look like, negative infinity to 14 inclusive, because anything greater than 14 gives us a negative number, and then we'd have our function would be equal to an imaginary number. All right, so the third problem that we're being asked to evaluate, find the domain, is f of x equals 1 over x minus 6. All right, so here or just like we did earlier, similarly as we did in the other earlier video, x cannot be equal to 6 because then we'd get an indeterminate number. Here we'd have a 0 in the denominator, and we can't have that. So x can't be 6. It could be anything else, but it can't be 6. So in this case, we would have our domain is negative infinity to 6, but not including 6, so it's a parentheses. And then it's also the union of from 6 to infinity. So I feel like all we're doing for the domain is finding out what the possible values of x can be. And in this case, x can't be 6. And so we would write that it can be from negative infinity to 6, and that it can be, and that's the union of 6 to infinity. And that's all there is to finding the domain of that problem. This one's a little bit harder, but not much. We have h of x equals x over x squared plus 4x minus 21. All right? So we get to, we're trying to find what the restrictions are for x. Are there any restrictions on what x can be for the domain? Well, up in the numerator, no, the x can be anything up in the numerator. Down here in the denominator, we can't have any values for x that are going to give us a 0 down here. So we have to find if there are any values of x that will give us a 0 in the denominator and rule those out for the domain. And the way that we're going to find if there's any zeros for the denominator is we're going to factor it. So we get a little refresher on factoring, okay? And so we're trying to find the factors of 1 over here and negative 21. That when added together will give us a 4x. So the factors of negative 21 are 1 and negative 21, 3 and negative 7, negative 7 and 3, and negative 1 and 21. So what factors add up to a positive 4? And that's going to be your factors right here, 3 and negative 7. So we factor this and say x plus 3. Oops, sorry, I messed that up. It's not, I wrote the same thing down here twice. It's actually negative 3 and 7 and negative 1 and 21. So the factors that add up to a positive 4 will be our negative 3 and 7. So x minus 3, x plus 7. So if either one of these are equal to 0, then we'll have a 0 in the denominator and it's indeterminate. So this will be equal to 0 when x is 3 or x is negative 7. So those are the zeros of this quadratic, which we don't want in this case because we're trying to find the restrictions on the domain. So in this case, the domain can be negative infinity up to but not including negative 7. And then it can be anything from negative 7 to 3. And then it can also be anything from 3 to infinity. But it can't be 3 and it can't be negative 7. So to write the domain, we have to write it like this. It's a negative infinity to negative 7, but not including negative 7. And that's the union with negative 7, the interval from negative 7 to 3. And that's the union from the interval from 3 to infinity. Like I said, it's a little bit harder, but remember, what you're trying to do is when you're asked to find the domain, is find any restrictions on what the values of x can be. So then you have to look at your function and see what your restrictions on your function are. In this case, you can't have 0 down here. And you work from there. It's a little bit of math, it's a little bit of logic, but remember what you're trying to find, and you can go from there.